This is how lithium-ion batteries are made: precision machines, automated systems, and industrial perfection, step by step. Follow IndusTech for more satisfying manufacturing processes, and comment what we should show next. First, lithium ore is ground into a fine powder, ready for processing. From there, the conveyor belt will smoothly transport the lithium powder to the next station. At the same time, the rotating drums thoroughly mix the lithium compounds until they are completely homogeneous. Meanwhile, a high-speed mixer will thoroughly mix the cadmium powder. Next, precision machinery will cut the lithium sheets with perfect edges. Following that, a vibrating screen will separate the particles into uniform sizes. Once finished, the powder will flow evenly into the containers without spilling out. I'm just kidding. After that, robotic arms will precisely move the powder to the next stage. As the material moves forward, the powder is evenly distributed onto the conveyor belt to ensure a steady flow. At this stage, the machinery will flatten the powder into smooth and even layers. Immediately afterward, industrial excavators will rhythmically scoop the powder into containers. In parallel, additives are carefully added to the mixture to create a uniform coating. At the same time, machines inspect the lithium crystals to ensure uniform size and quality. During the inspection process, the industrial vacuum cleaner effectively removes excess powder. Once validated, the hoppers will release precisely measured streams of powder. During the discharge phase, the rotating drums will evenly distribute the powder, preventing spillage. Simultaneously, sensors continuously monitor the powder level to ensure accuracy. Throughout the process, liquid additives are slowly poured into the mixer. Finally, the finished powder mixture is discharged, ready for the next stage. First, cathode slurry is coated evenly onto aluminum foil. Next, graphite forms a smooth anode layer on copper foil. Then, electrode sheets move continuously through precision rollers. After that, sheets are cut into exact, uniform dimensions. At this stage, heat removes moisture from coated electrodes. Once dried, electrodes cool gradually to stabilize the coating. Meanwhile, sensors verify coating thickness within tolerance. At the same time, cathode sheets are stacked with perfect alignment. Following this, vacuum drying removes remaining internal moisture. Here, cameras inspect edges and surface quality. Next, rollers compress sheets to uniform thickness. From here, electrodes are wound into precise spiral structures. Afterward, sheets move smoothly to the next station. Meanwhile, active materials are mixed into a uniform slurry. To maintain quality, coating rollers are automatically cleaned. Next, UV light cures the electrode surface evenly. At this point, graphite particles are pressed firmly onto foil. Here, robotic arms align electrode stacks precisely. Before moving on, metal detectors scan for contamination. Finally, cathode sheets are rolled into perfect cylinders. Next, cell assembly begins. First, anode, separator, and cathode layers are stacked with perfect precision. Next, the layered materials are wound into uniform lithium-ion cells. Then, electrolyte is filled into each cell with a carefully controlled level. After that, battery cases are sealed using ultrasonic precision. Once sealed, robotic arms load the cells into formation racks with exact placement. At this point, the cells move along conveyors in perfectly aligned rows. Meanwhile, safety vents are inserted automatically and centered precisely. Inside the cells, electrolyte slowly absorbs into the internal electrode layers. At the same time, robotic systems align battery cells into flawless rows. From here, separator films wind together with cathode and anode sheets to form the internal spiral. Next, finished electrode spirals are inserted precisely into battery casings. Following this, the cells enter vacuum chambers for complete electrolyte saturation. Then, automated stations inject measured electrolyte with absolute accuracy. Afterward, sealing presses close the battery casings evenly and securely. At this stage, laser scanners inspect each seal for microscopic defects. Once approved, the sealed cells are transported smoothly toward the formation area. Here, the cells are prepared for controlled charging during formation. Meanwhile, robotic units polish the outer surfaces to a smooth metallic finish. Finally, X-ray systems scan the internal structure to ensure perfect alignment. Next, the assembled cells enter the formation and aging stage. Now, lithium-ion cells are placed into formation racks with precise electrical connections. Next, the initial charging process begins to activate the cell's internal chemistry. Then, the cells discharge in a fully controlled and synchronized cycle. After that, repeated charge and discharge cycles stabilize the internal structure. Meanwhile, thermal monitoring systems track temperature to keep conditions balanced. Once stabilized, the cells enter aging racks for controlled resting and stabilization. At the same time, environmental systems regulate humidity and temperature automatically. During aging, robotic systems rotate the cells to ensure uniform stabilization. After aging, automated probes test voltage levels with high precision. Next, each cell's capacity is measured and recorded accurately. Following this, internal resistance is tested to verify electrical performance. If any issues appear, non-conforming cells are safely diverted from the main line. Meanwhile, approved cells move smoothly toward final processing. Before marking, robotic cleaning removes dust and surface residues. Then, laser systems engrave identification codes onto each cell. After marking, optical inspection scans surfaces for any defects. Next, robotic arms transfer inspected cells into packaging lanes. To ensure durability, shock and vibration tests simulate real-world stress. Finally, automated systems confirm that each cell meets all specifications. Once every cell is approved and fully stabilized, the process moves to packaging, storage, and final dispatch. Now, approved battery cells are carefully placed into protective trays for safe handling. Next, automated scales verify the final weight of each packaged batch. Then, robotic systems arrange the cells precisely inside shipping containers. After that, protective padding is added to prevent movement during transport. Once secured, sealing machines close each container with consistent pressure. Meanwhile, barcode systems apply tracking labels for logistics identification. Following this, containers are transferred into automated warehouse storage. At the same time, environmental sensors monitor conditions to ensure safe storage. When orders are ready, automated systems retrieve containers for shipment. Before dispatch, scanners perform a final inspection of each container. Next, conveyors transport sealed containers toward the loading area. Then, robotic systems stack containers neatly onto pallets. After stacking, pallets are wrapped to secure the load for transport. Before moving out, automated sensors verify weight balance and stability. Meanwhile, robotic forklifts transport pallets through the facility. As departure approaches, loading docks prepare pallets for shipment. Next, pallets are loaded into transport vehicles with precise alignment. After loading, shipment data is logged into the documentation system. Finally, the production line completes its cycle, ready for the next batch. Thanks for watching this complete lithium-ion battery manufacturing process. If you enjoyed seeing how industrial machines work together with such precision, give this video a like, follow IndusTech for more satisfying manufacturing processes, and comment what production line you want to see next.